Hello, Java User Group Stockholm. I was invited by Victor, so thank you for the invitation. And I was asked to stream it via YouTube. And so what I do right now, and I actually opened all the limits, so we can have as many attendees as we like. So it's already really well attended. So thank you for coming and listening. So we have, I would say, somehow interesting topic, right? Java E Was Serverless. Now comes Cloud Quarkus. And I would like to actually prove the point during the presentation. And your job is to ask questions. So this is how it works, right? Or to challenge me, or say, okay, is this not right? How you see the world? And yes. So the chat is hyperactive. You can ask me questions via chat, and I'm watching the chat here. So already hello to everyone. And I also will monitor Twitter, but Twitter is usually lazy, so chat is always way better. So yeah, hello everybody, and I would say let's start with the show. So the Java User Group Stockholm is a very young one, but already has 52 members. So, and we have lots of great guests. So after me, Nikolai Parlok will come. He is really great. So we had already podcasts and podcasts. Somewhere there is, wait a sec, I even prepared here podcast. So with Nikolai, so AHEX FM is my fun podcast, and we had already 2 episodes with Nikolai, so you can listen. He's a really great guy, and Nikolai got the 100,000 subscribers on YouTube. So the silver plate on YouTube. So you have to join the next Java User Group Stockholm group. And of course, the master. This is the Venkat is there. And Abdel also will talk about service mesh. So it seems like the Java User Group Stockholm is hyperactive, which is a really good thing. So I have a YouTube YouTube account, of course. Twitter, but I mostly use Twitter to point to my content. Then there is the AHEX, how to call it, user group or meetup, with some upcoming conferences as well. So if you like, check it out. And if you wonder why there's always 15 attendees, and sometimes people are not that nice. I don't like to compete with the organizers, and what I do, I restrict the number of guests. So it is preferred that you register the conference before watching here on YouTube. But I have to register the event somehow, and for online event I need a link. So this is how I got the idea, to stream for a small group of people always on YouTube. So that's the idea. And yeah, this is the if you like, join this group. Now I think this basically was, and now we can start with the content. So everyone says hello. I'm curious who will ask the very first question. I think Victor should ask the first question, right? If he invited me, should also know to do something for it, right? Now open the slides. Yeah, and I actually prepare a lot of slides. So this was this slide animation, and reuse some of the slides. So let's start with the show. Now I got Victor asked me about joining, invited me to the Java User Group, and I thought, okay, what I can do, and so I delivered a similar talk already for MicroStream, and I reused some slides. But I think I can explain you what I mean by this, and why I'm talking about serverless. If you know me, I talk a lot about, or I use Java E a lot, and I still use Java E a lot. But I will try to explain, what I mean by this title. So I really like Java, really enjoy it, and I would say I use Java even more than ever. And yeah, so about me, I have some pre-recorded courses if you are interested. This is the AHEX.io. AHEX News is like just marketing. So what I'm doing, I'm announcing some of the events like AHEX Live. This is the podcast already mentioned. My blog is like notebook. So what I already did, I created some bookmarks to the content. So this will be from my blog. And there are upcoming related, actually highly related workshops, AHEX Live. There are already enough attendees. So if you, they will definitely take place. So this is what I would like to say. And there's this end of March, serverless architecture with AWS Lambda. Everything Java, no YAML, pure Java, Maven, and, you know, very similar what we did all the years, you know, almost like Thin Wars, but in the cloud. And this one, the second one, this is actually the first time I'm doing this. What I will do, I will prepare lots of examples and applications, and we walk through the code. And they're not only going to be, you know, examples like Hello World, more like best practices, because it's really hard to implement a best practice during the course. So I will do it upfront and discuss with you, and you can take, you know, the code with you. So this is the idea. But this is in May. Okay, now, and if there are any questions left, first Monday of the month, Airhacks TV. Now maybe, also friend of the show, Mr. Guru, and his handle is Java Guru, which is great. Hello Adam, could you show how to deploy to ECS Fargate a Quarkus app using AWS CDK? That has a load balance public URL. I could. This is really simple, and yes, I could. I actually could, but I would like to show you today Lambda. With the public URL is almost done. What you can do is you can use a pre-built construct. This is almost done. So the name is like ECS Fargate. I think public something. This is the name. So we'll have to look it up. And it is actually what you're asking here is way easier than whatever we'll talk today. So this is the hello world of serverless. But I will do it on Airhacks Live for sure. And yeah, maybe I will show you how to how it is working. Now, okay, evolution. So and I will introduce myself with the slides here. So start with this. My very beginning of server-side Java was the Sun Java web server. And the story is, I was asked by a, hopefully you can hear me at all. Yeah. Hey, Nebraska, USA. Nebraska joins, you know, Stockholm Java user group. This is great. So here's the chat. So where is it? Yeah. So it's Jeff Rogers from Nebraska. I assume Nebraska is still cold, right? Okay, I started with Sun Java web server. So I did Java before, and I was asked to do something on the server side. And people expected me back then to use CGI and Perl. I had no idea about Perl, but I used already Java. And I knew Sun Java web server will came out, and it looks like this. So this was the origin Sun website I found on Internet Archives. And this is actually not true. I see it right now. So this slide is wrong. What this should be is, this is the Sun Java web server, and these are the packages, deployment units. And as I remember, no, there could be multiple. There could be multiple jars, but what was hard to set up the drivers, like Oracle drivers. So this is right. So it's about right. So the Sun Java web server was available with the very first servlet specification, but there was not even web XML deployment descriptors. So I downloaded this at the end of the year, I don't know, 1997, and this was my very first server-side Java project. I downloaded it a few hours after it became available. So I had to buy it from USA and download. Now, the website here, you see 1998, but this was already Java Web Server 2.0. I started with 1, and the cool story is what they are propagating here. You see here, they say, write ones run everywhere without having to port old CGI scripts. This was my hope. So this were my very first project, a couple of projects we did with Java Web Server. It came with a nice admin console. It was really great experience. So now, next slide. This was the J2E application server. So why I was interested in J2E application server at all? Similar situation to right now web stuff. There were, no kidding, 20, 30 different application servers, everyone behaving completely differently. I was absolutely not interested to learn 20, 30 different vendor-specific technologies. So J2E came later. I started actually, EJBs came before J2E, I was absolutely not interested in EJBs at the beginning, because for me it was, we started with the Java web server, it didn't support EJBs, so we had our own servlet container, we used Java Beans and JDBC, and of course we managed transactions by ourselves via JDBC, and then EJB came out, so okay, what did solve? Nothing. And you had back then, there was no XML. Interestingly, there was a DSL for configuration of EJBs in 1.0. And then J2E came out, and what J2E did, it provided APIs to to all these specs. So before J2E, there was JMS, of course. You could use JMS, you could use JDBC, JNDI, but you had to pick the APIs, individual APIs, and what you could do, you could pick different versions. So every server was a unique snowflake. So I was really eager to learn J2E, because for me it was the best invention ever. I only have to learn a common set of APIs and be productive. And at the beginning, there was a clear distinction of web containers and EJB containers. And the cool story is that interesting story is, back then, architects believed that if you separate the web container and EJB container, you can increase the scalability, because you get two servers, two processes which communicate with each other. So this was back then, and of course everything became complicated, and I don't know whether, maybe it scaled better, but I never even tried that. For me, the web container and EJB container run always on the same machine, and the web container called EJB container via local interfaces. So this was, I would say, 1 year later, around 2002 maybe, it was clear that the web container should talk to the EJB container via local interfaces. Yeah, and this was the J2E application server. So now of course, this yellow rectangle means a deployment unit. So there were the wars and there were the EJB jars. And at the Java web server time, I don't even know what it was. It was, I think it was a zip or jar. What I remember is it was impossible to install JDBC drivers, so we had to use Oracle. What I did, I extracted the Java web server, and the jar of the Java server, I packed, the Oracle JDBC drivers intermingled with the Java web server, and this is how I installed the JDBC drivers. Yeah. Now, the next evolution was web and EJB container in the same machine. This is what we already talked about. And one later, CDI came out. This was Java E application servers and web and EJB container. What I mean by that here is wars. So I think it was around 2005. There was the idea that we can actually have in a war everything. And the EJBs became actually just a Java class which is annotated. So this is what EJBs, so we just injected them with @EJB, and later on the next slide, this was the main difference with @inject. And JAX-RS was hugely popular. So JAX-RS was everyone actually liked JAX-RS. This is the REST endpoint, and the architecture was like JAX-RS replaced more or less servlets, and JAX-RS provided the endpoints, the REST endpoints, and talked indirectly to first EJBs and then CDI beans. And this remained until now. Jakarta eServer, like Payara, Whitefly, OpenLiberty are still the same architecture. Works well. The server are still small and lightweight. Okay, now the next evolution is MicroProfile runtime, and this is actually the interesting story. So I always refer to application servers, but Quarkus or Helidon or Micronode are not necessarily servers. Why not? Because there is no more deployment. So the server and the applications are one thing, and this is maybe the major distinction. And this is a runtime, and a MicroProfile runtime is also something like Payara, right? Because Payara has complete MicroProfile support, or OpenLiberty. It doesn't have to be Quarkus, which is a very good thing. And so Docker, also funny. I started to use Docker on my server very, very early. I used it before it was even stable. So I remember my file system became corrupt. It was like Docker 0.6 or something. And why I use Docker from day one is because for me, Docker was a great solution for backups. So with Docker, I could, pick an empty machine and just install my software. I knew it'd run. Prior to Docker, I always have, to document my script or whatever I do. I always forgot what I did. But with Docker, I got, a repeatable approach how to install Java stuff on a blank server. Yeah, this is basically MicroProfile with Docker. And what is the next evolution step? The next evolution step I will talk about today, and by the way, I forgot actually 1 or 2 slides. So this is also no more true. What we should use here is just one yellow spot. And now back to some history. In the year, this is always funny, 9 years ago, this is the lacking slide. I wrote a post, why not one application per server domain? And this was actually very late, so I just wrote it because people still try to optimize the application servers with shared deployments. And back then here, what I did is I said, okay, I actually for years, since Java is 6, there's always one server on one Docker on one application. So there's one container instance, one application server instance, and one war. This was for me a microservice. And I started with it with the advent of Java 6. Since war became available, my observation was it is not worth to save RAM, and have shared deployments. And the downsides is, I actually wrote it down here. The downsides, the downsides are with shared deployments, it is harder to observe, harder to make it more robust because one noisy war, right? A noisy neighbor problem. One war can just pick all the stuff. It is harder to monitor. So there was actually no advantages, and so this was actually the start of microservices. And back then, for me, it was a microservice. Period. Okay, this was. This, and just saying, this is what I tell you today is nothing new. It is not 9 years old. Also, there is the perfect Java E microservice. How old is this post? 1 year younger. And what I said back then, 10 years old, what we should do, you should have, a nicely structured, how to call it, Java project, right? A one single Java project with nice internal structure, with packages, and every package comes with maximal cohesion, minimal coupling, like component-based development. Why? Because it's easier to find stuff, and we always use the same structure, BCE or ECB, for years. Actually, right now I'm using building a serverless project, and we have exactly the same structure. So, and a funny thing is, nowadays, we are in serverless world, and we do exactly the same. So from code perspective, there is no difference. And from the conceptual perspective, almost no difference. And this is what I would actually like to tell you today. So, Umea, Java user group. And I forgot how to pronounce Umea. This is Umu or something. And I actually delivered a talk years ago, and what I remember is that the Umea Java user group in Sweden is almost on the North Pole, and this is one of the northest Java user groups ever. So, greetings to Umea, and also remember, I was hired for the Umea University to review some stuff. So thank you for that, and lots of attendees attended, or lots of, how to call it, Umea University workers attended the EHEX workshop, so thank you for that. So where I'm going with it is a 10 years old J2E project. So, practice is not even best practice, like common sense practices are absolutely applicable on Lambda. You will see it in a second. Okay, now we have it. And now let's see. This was the slide, and now we only have reasonable stuff. Okay, if you like to This is the workshops. They are around the corner, so we'll spend the entire day working on it. And you already saw the podcast. So, okay, now. So we have now MicroProfile runtime and Docker container runtime. So what I would like to do is, let's see. So we have roughly 1 hour. Now, which role plays Quarkus? Now, if you take a look on that, wait a sec, I will have to reopen that. Now it's better. So we had the Jakarta application server, then we got Docker container with MicroProfile runtime, and now we get the serverless runtime. Now, which role plays Quarkus? So what you already saw 9 years ago, I told you right now, we always had the one-to-one relation between applications, servers, and wars. And if you have one-to-one relation between applications and servers and wars, the question is, why we need, you know, the entire deployment stuff, the deployment mechanism and reflection. And the application servers were always capable at runtime hot deployment to hot deploy your war. This was one of the, you know, the features of application servers. But since Docker became available, I actually never used the hot deployment again because it is almost impossible in Docker. So for me, I never used that because it's crazy. And you could do this, but you shouldn't. And it also, you know, it was against, you know, the immutable infrastructure idea and everything. So we just, you know, moved forward. You always deliver new immutable containers to the cloud, and we were actually perfectly, you know, compatible with all the 12-factor apps and all the patterns back then. So it was, everyone talked about cloud native, and we said, okay, there is no difference, you know, to 10 years ago. This is what how Java E behaved. Now, why Java E was serverless? Now, because this is in the title, Java E was serverless. So in most enterprise companies, we were actually not allowed to run our own servers. So the infrastructure and the packages, the wars, were strictly separated. So sometimes, you know, we had to send, you know, the war, throw the war over the wall, right? And someone else cared about the application servers. And we had, you know, in some companies, people had to pay, you know, upfront, you know, to say, okay, if we order an application server with 4 cores, it will cost that much, and with this RAM and so forth. So it was configurable. And actually, we just created the war and deployed was by someone else. So we never saw the server. So, and the idea for me, it was always serverless. So this is actually the entire point of Java E was always, and actually at the beginning, there were even roles, Java E roles, like, you know, the deployer, the component developer, whatever. So what means the application server, strangely enough, played almost no role in the entire process, except you worked locally. So it was always, you know, strictly separated. And what I also did a lot, I referred to thin wars. It's okay, in the war, there's just business logic. I don't care, and the application server is somewhere else, and the application servers are replaceable. Now, why I talk actually about serverless? Because in serverless, this is almost the same. So the only difference is here, in a serverless environment like AWS Lambda, what I will show you today, there is actually no difference between conceptual difference, except right now we are running on Lambda and not on application server, but it is almost the same code and the same concepts. And this is why I actually like serverless a lot, because this is at least, you know, a step forward. So if we now, okay, what I didn't explain you today is why I'm talking about clouds at all. Because, you know, clouds are actually, in most cases, more expensive. So I think it is really hard to be cheaper with a public cloud. And so in most cases, more expensive than, you know, in on-premise deployment. Now the question is, why to go to the cloud at all? So, and what I got, you know, in the last 2-3 years, there were killer use cases for the clouds were almost unsolvable on-premise. You know, starting with the weakest of all cases is infrastructure as code. You can automate everything with the cloud. You cannot always automate your own data center because they are, you know, they are built with less, how to call it, love, right? And but the most stronger is disaster recovery. So I am in some projects where we have the requirement to ship the software into two different data centers. and they have to be separated for this disaster recovery. It's really hard to achieve sometimes on premise. And of course, security. The clouds are certified, you know, they are better certified than most on-premise data centers, and there are best practices in place, what to do, you know, to rotate the certificates and stuff like that. And therefore, in the last 2-3 years, I actually exclusively working with public clouds. Having said that, my public clouds are not that public. So what Guru asked me right now is for the AWS ECS Fargate. This is actually exception from the rule. In most projects, we are using a public cloud, but the stuff we are shipping is not visible to the outside world. The cloud is more or less extension from the intranet. So in most cases on Azure, it is express routes. On AWS, is called Direct Connect. So you are connecting, or VPN, you are connecting directly to the VPC, and you are not talking via public internet with the cloud. Okay, so we have 2 questions maybe. Let's see. Sulu asked me, Mukahit, hello, I develop a project using Jakarta E, EJB Jakarta E security, but I'm having problems on the server side. I'm using Glassfish. 6. Okay, then if possible, migrate to Payara. I used Whitefly and Payara before, but I always had problems. Do you have a server recommendation? If you have on Glassfish 6, pick the recent Payara. This is my recommendation, for sure. So this is my absolute recommendation. And speaking about Payara, what you should check, there's a great project from Payara called Payara Cloud. And what Payara Cloud does, Payara Cloud is like a Kubernetes operator on top of in the cloud, and it manages the deployment for you. So you're running, you know, on the cloud without knowing it. So Payara Cloud, check it out. Okay, so wait a second. Where are my slides? Yeah. Okay, so now I think you got the idea here. So let's see what we have. The cloud evolution. So, and what I talked right now, that, you know, the disaster recovery, security, and so forth. Now, if I already go to the cloud, now the question is why I should do the same as before. This is like, for me, like refactoring, you know, everything gets more expensive and there is no added value to my clients. So, and this is like, you know, what I also forgot, you know, all the, you know, security problems in the recent years also raised the expectations that we care a little bit more about security, right? So this is the shared responsibility model from AWS, and what it means is, so you are responsible, or AWS is responsible for the yellow part or orange part, and you, developer, is responsible for the blue part. So, because I played with Java a lot, as you already learned, you know, since 1997, I'm no more interested, you know, to reevaluate whatever is already evaluated, right? So I would like to focus on the more interesting stuff. So what I would like to do is to move this orange part as far up as possible, right? So I would like, you know, just to care about my thin war and not about, you know, I don't know, server-side encryption and whatever, right? Now, and therefore, there's this is another chart from AWS. This is for AWS Lambda, and this is the AWS Lambda is one of the technologies where, you know, it picks the most. It is the most orange technology on Amazon. So what I just interesting in this is the resource configuration, which is it reminds me of JVM configuration. So you say, I need this amount of RAM and I need this runtime, Java 11, and I'm set. Then I have to know, in some project, care about IAM roles. If you're not talking to a database, it happens behind the scenes. And you only care about the function. The cool story is, with Thin Wars, we never had any external libraries, so I don't have to care about the libraries. So for me, it is Lambda, AWS Lambda is like the application server on steroids. And it is hard to believe, but if I show this to my clients and projects, the developers really like it. Okay, this is now Lambda, and interestingly, Lambda, it does not run on Docker container, it runs on virtual machine, which is quite important because the isolation is higher, but the virtual machine is very, very fast. So the subsequent Lambda calls are really under 100 milliseconds in Java, so it is extremely fast. And of course, I'm just waiting for now for the question, what about cold start? So if you hit the Lambda the very first time, it takes 3 seconds, 5 seconds, and the subsequent calls are very, very fast. So this is how Lambda behaves. Okay, so this was a lot of slides. So now Quarkus, right? So what's the deal with Quarkus? Now, I just, I explained 2 topics in parallel. I stopped to explaining Quarkus. So what I told you, my observation was 1 application server, 1 war, and there was no hot deployment, but the application server was always capable of hot deploying. Now, I didn't care because the overhead of application servers was not that high. So I measured, RAM. There are lots of YouTube videos, and I think at the DevOps in Belgium, I compared the application server to Chrome and say, okay, the application server is actually smaller than the Chrome browser back then, which is not a big challenge, but still. And but what Quarkus did, this is actually I would say, the major achievement of Quarkus. They did the same observation and say, look, if there is no shared deployment, we just remove everything which is required to have shared deployment. I like the idea because I like to delete stuff. So what Quarkus did, it said, okay, for hot deployment, we need reflection. Why? Because you have to look up code which you don't know. It's you are scanning, you are scanning the war, you find a class, and say, okay, I have to load the class dynamically. Then you go through the annotations and you create interceptors. And Quarkus said, okay, there will be no dynamic deployment. If there is no dynamic deployment, then there should be, you don't need reflection. Now the question is, what Quarkus does with the dependency injection. What Quarkus does is, at build time, the Quarkus extension, it searches, for deployment descriptors, for annotations, and generates bytecode in advance. This is what Quarkus does. And what it means is, at runtime, there's no reflection. If there's no reflection, it's a little bit safer. And of course, there is no XML parsers, no class loaders. Everything is simpler. So I would say application servers, the deployment was crazy simple. It was just copying the war, or the build process was, actually there was no build process, right, on application servers. You could have an application server, it runs somewhere, and just put, the war. On Quarkus, you absolutely need the build step because it actually merges your application with Quarkus, and the extensions are reading the metadata and then generating bytecode in advance. The Java guru asked me, what is my opinion about App Runner? I think you mean the AWS App Runner. So there's the App Runner, there is Elastic Beanstalk, and there is the Lightsail, are very similar services. And the App Runner is more like the next step. So there was the Beanstalk, and App Runner is the next step. So in Beanstalk, what AWS Beanstalk is, it generates for the load balancers and everything up front, and the App Runner it still does it, but behind the scenes. So it is more like more convenient approach. But bear with me. Where is my slide? So. And with Quarkus, it generated the bytecode. So what it means is, it starts crazy fast. Why? It starts as fast as your main method, because there is no magic, no class loaders, no reflection, and reflection is the slowest possible thing you can have in Java. So this is slower than anything else. And so if Quarkus starts small, and because there's no reflection, there's also no class caching, so it is also very small in size. So I would say Quarkus is maybe one of the smallest runtimes, Quarkus and Micronaut, you can currently get in Java. And this basically, the story about Quarkus means what Quarkus does, it deploys at build time. The next interesting part is Quarkus supports full MicroProfile. So I would say 99% of MicroProfile plus parts of Jakarta E. So you can actually pick an old Jakarta E application and migrate it with a little effort to Quarkus. Why? For instance, someone asked me about Glassfish 6. What you could do? You could migrate from Glassfish 6 to Payara, then migrate in Payara to the highest possible MicroProfile standard, and then it's fairly sure then the application will run on Quarkus as well, because MicroProfile is MicroProfile, it's the same API. So I would say Quarkus is like, you know, an application server runtime, which deploys at build time. This is how I understand Quarkus. Okay, so we have it. This is a little bit later. I would say, let's take a look at Quarkus. No disruption. Java Guru, what I ask you now to ask questions. So ask questions the entire time, and I will try to answer them. And yeah. And this is just Java user group. You should have fun. We all should have fun, you know. There is no disruption, no interruptions, no disruptions, just fun. Now, create. This is the recent Quarkus. And group ID Aws and JUG Stockholm. JUG Stock version, the recent one, no extensions. We'd like to yes, a little bit of code is never JUG Stock code, Visual Studio Code. And take a look at the POM. So the POM, it just comes with 2 extensions, and this REST easy exposes the API, actually JAX-RS. So if you take a look, it exactly looks like JAX-RS, what I showed you the last 10 years. No difference. So now Maven clean package. Now comes the interesting part. So if I build that and take a look at the target, what I told you, that the Quarkus and the application is one thing. This was not precise. If we take a look what happens behind the scenes here, you see there is a Quarkus app which you can launch. So we can go here and say java-jar target Quarkus run. Yeah, and it started in 0.3 seconds. So this was the regular Java 17 start, so we can do it again. Started. So yeah, this is how Quarkus behaves. No GraalVM, nothing. It's just plain Java. Now what I can also do is a little bit slower. I can say compile Quarkus dev, and then it will start in dev mode. So now it's a little bit slower, so 600 milliseconds. But what I can do with it, I can actually go here and say I would like to have this, and this is already Quarkus, and I could actually invoke here hello, and say here thank you for all the questions. And if I reload that, it should completely reload and see thank you for all the questions. So the Quarkus dev mode is actually great for testing, and I show you some ideas what we can do in serverless world. Now I get some, you know, the chat is great. So when I grow up, I want to be like you. Thank you. Why this? I mean, I'm just then you will program, you know, the entire day hello worlds, right? So this is, I don't know whether it's a good idea. Does Quarkus allow dependencies that use reflection? Florian Huber asked me. The answer is absolutely. You can have reflection. The only problem is they are slow. So, okay. I can actually put here whatever I like. So these dependencies are extensions. What extensions are? This is like a specific dependency which knows Quarkus, internal Quarkus API, and it is 2 halves, runtime and build time extension. And the build time extension reads, you know, the dependencies, generates the bytecode, and the runtime extension cares about, you know, the runtime dependency. But you can add here whatever you like. So in one project, we use an old DB2 host JDBC driver, and it worked. But you won't be able to, or most likely, you won't be able to use GraalVM, because what Quarkus also does, it knows about all the dependencies and passes the dependencies to GraalVM, and GraalVM creates the native image. And you can use GraalVM, or you can use Mandrel, which is you get enterprise support from Red Hat, and you can buy for GraalVM enterprise support from Oracle if you are a larger project. So the answer is you can use whatever you like, but it is a wise idea to use extensions. Also, extension gets reloaded in the development mode, but a regular extensions not that, right? So no Maven clean install. I always do actually Maven clean install, but today I thought, I'm in good mood. I have lots of slides. Nothing can go wrong, right? So, okay. So now we have a basic Quarkus application. Of course, I will stop on this point. Dependency injection and so forth. I show you later. I could add, at runtime the dependencies and the Quarkus is small. You maybe already saw that. So if I would open JVisual VM, you will see there's almost no RAM. So go to my YouTube channel actually, and you will see lots of Quarkus videos. So there's I don't like to repeat too much. Now, about serverless, we are not in the serverless mode yet. So this is a Lambda, and the question is, who cares about that? Okay, this is a little bit faster, but what's actually the deal with serverless? So as serverless came out, the term came out, I really hated that because it came out from developers, and I said, this is the most stupid thing. We have servers everywhere. What this serverless means, but what this serverless means, the term is, you don't have to care about the servers. So that's the entire point. And this is actually what I told you already. This is why Java E servers were actually serverless always, because I never cared about the particular vendor. So I just wrote, the war and copied somewhere and it ran. Yeah, right? This was actually exactly the same idea, like in Lambda case. So, James Logan asked me, what are use cases for Quarkus? I would say, if you are happy with Wildfly Payara, you can still run it. So there is no need to use Quarkus. One of the use cases in Quarkus, one killer use case, I will show you in a second. Also, okay, one killer use case I will show you in a second. Another use case is you can create with Quarkus command line applications in native mode, which I use a lot. Lots of my standalone tools, even my podcast feed is generated with Quarkus as command line application. So you can just do this. The native mode, you can write applications in native mode which start quickly, for instance, batch processing or something, right? So I would say there's no killer use case for Quarkus if you are happy with Wildfly, Payara, Open Liberty. Quarkus is more like the next generation. This is the completely rethought server, right? Jan Kutzma says, from thin to fat clients. I don't get it, but maybe. Maybe you're right, but from thin to fat clients on the back. I don't know what you mean from thin to fat clients. So you have to be more precise, Jan. I don't know what to tell you about that. Hopefully you are in the right session. Okay. Now the deal is serverless, so you don't have to care about servers. Okay, this is interesting. But what's really interesting for me is so in some projects I get asked by clients which need a solution, so they don't care a lot about the technology. Say, look, we go to the cloud. Which technology should we pick? That's the interesting part, right? So, and now, why I think the serverless is the absolute future is because the billing is different across all clouds. So what I mean by that? What already Guru asked me, developer joy. Yeah, okay. You are right. Developer joy is important. But my developer joy is eliminating dependencies in strange frameworks, so I don't have to relearn, every 2 weeks another framework because they tend all to die too early. And therefore, I have more fun. So if you observe me all the years, I have fun and lots of vacations because, I don't have to chase any other day different frameworks. And by the way, my strategy in Quarkus is focus on MicroProfile and the standards which are focused the last 20 years, and ignore all the esoteric Quarkus extensions if I don't need them. Why? Because the chances are high that most of the extensions won't survive the next 2 to 5 years, right? And if I would suggest to my clients, in 2 years they have to migrate somewhere else. But if they use MicroProfile related or more standardized extension, the chances are lower that they will disappear. Because, for instance, the entire MicroProfile is based on small-ri in Quarkus. And small-ri is also used by OpenLiberty and Whitefly. So this is my thinking. It works well so far. Now, Jeff asked me, let's see, you don't see the chat. So Jeff asked me, does it matter between Payara, Helidon, or Quarkus if you're using Jakarta and MicroProfile as they all end up in a jar? It doesn't matter at all. So actually, what I usually do is set up a Jakarta EE project. I call it Jeff. And if we open the project, so we have a Jeff and the system test for Jeff, which is interesting, is Jeff's partner. Is probably the system test of Jeff. And if you take a look, this was my setup, outside Quarkus, not this, rather than, where is it? Here. So I always included Jakarta API and MicroProfile. It's a little bit outdated, the MicroProfile, both. And because it's provided, you always used the API. You have to be careful with Quarkus because Quarkus does not support everything from Jakarta. It doesn't support EGBs, but what Quarkus supports is bean validation. It supports WebSockets. What else? Transactions, but not JSF indirectly. Servlets. It supports servlets, but I never use servlets on Quarkus. So it doesn't matter, Jeff. You can it has to be provider dependency, and you have to double check whether the API is available on Quarkus. But in Quarkus, I would use extensions which are shipping with Quarkus, right? So if I would like, for instance, if I would like to have, let's say, fault tolerance, right? So I go here and say, where is Quarkus? And say fault tolerance, and I would always use the small-ri fault tolerance, and I hopefully have it. So this is the fault tolerance for MicroProfile. And another one is going to be health. Always you pick MicroProfile health. So this is the next one. So I have already 2 dependencies. So and then whatever is small-ri is good. So my projects usually ships with most of these MicroProfile dependencies, and this is where it looks everywhere. How it looks everywhere. Okay, now another question. So you are hyperactive, which is good. So I meant from Lambdas over microservices to monolith, all possible with Quarkus. Absolutely, Jan. Yes, it is true. And actually, what I'm a strong believer in, it's called fed lambdas, where I put, this is my lambda. It almost looks like a large microservice, and it doesn't hurt. So this is the interesting part. So in my current project, we are roughly 300 classes, and it's still crazy fast. So it is larger than most of microservices, and it behaves great. Now, but what we will talk today is about this. Is the more, the more boring synchronous Lambda invocation. With Quarkus, you can also use Quarkus, in an asynchronous way. And but in all, what do you have to understand? The entire serverless model usually works with events. And today, they are, I would say, you won't see the events directly. They happen. They are the HTTP events. But if you are working with asynchronous Lambdas, events are the most important thing. So we get event-driven architectures, which make sense. For years, I was always asked, what is my opinion about event-driven architecture? I always told you, I don't get it. So why I should do this? And now the question is, why I changed my mind in the cloud? And the answer is because all these services in the cloud are already emitting events. So I don't have, to send an event and listen to the event. I only have to receive the events. So this is actually the great news. So it makes absolute sense. Now, why events are important? Because think about that. our Lambda is not alive. The event arrives from outside, and then the Lambda wakes up by the runtime, consumes the event, and Quarkus does something, and then goes sleeping again. So there is we need the event. It does not, it's not active the entire time, and and you are paid per event, per invocation. So this is why I believe that the serverless is the future, because pay as you go or pay per invocation, I can go to my manager and say, look, this use case was invoked 2 million times and you have paid this amount of money. And if it says, okay, I know it is not worth to keep it alive, then I say, okay, then we can kill it. But if you earn money with every transaction, so then we are talking, right? So, and if you run Kubernetes, Docker container, whatever, you have to, and Kubernetes actually, you will even have to pay for the control plane, regardless whether you are using this or not. So you will have to pay, for the entire month for the infrastructure. And this is for me no difference to on-premise. So, but serverless is this step forward. I only paying for what I use, which makes sense in the public cloud. It doesn't make a lot of sense on-premise, because the Lambda stuff comes with a little bit of overhead. You need the runtime, and most of the data centers are always on limit. So if you will introduce Lambda, it won't improve the situation. But in the public cloud, different story. There are lots of servers, so you can spread the load more efficiently. And of course, some companies already told me we use Lambda, we are more green, so it's also good for marketing, because they pay us. Means it's not like you have to keep your base workload running. You can scale on demand. So let's see. What other question? A general question: how do you find out about the tree shaking or internals of Quarkus micronode? Do you read the documentation? Sometimes I look at the source code and I read also documentation. Yes, I mean, at the beginning I was really curious how Quarkus operates, so I try to play it with the plugins. I deactivated the extensions, reactivated the extensions. Even the earliest Quarkus videos, if you go to YouTube 2 or 3 years ago. So what I recorded a video just without a plugin and I tried to explain what happens. And with Quarkus I also decompiled the code, which is shipped to find out what's going on. Okay, now, event-driven architecture is in the cloud very similar to Kafka true events. So the events do not travel, they just occur. So it means, if you submit something to a S3 bucket, an event is created and the event can be consumed by AWS Lambda. It's just configuration. You don't have to do anything. And this opens, this simplifies all the code and makes, how to call it, a complete new architecture is possible. A counterpart of it would be to create a Docker container with a JUG multi-part upload, which runs all the time, hoping that someone will upload a file. The file is uploaded, the file is then stored in a local file system and then distributed somewhere else. Or you say, I don't have a process at all, I'm uploading to S3. By the way, S3 is like a bucket. It's called blob storage on Azure, S3 on AWS. And it's serverless, so you don't have to run it. It's just always there, right? So I'm uploading my Excel file to S3, then my Lambda wakes up and does something with it. Okay, now, pay as you go. What I already see in projects, we are profiling, the dollars and not the CPU. So if something is expensive, we look at this and try to optimize that. And whether something is, how much RAM is consumed, or CPU is less important if it's cheap. So no activity, no charges. This is, I would say, the definition of serverless. So you should be able to scale down your entire system and don't pay anything. So this is the idea. Requests are proportional to costs. Cost-driven architectures. Yeah, I coined the term. I don't know. Maybe I heard it somewhere. But I say, okay, this is actually what you're doing. And monthly costs become the main non-functional requirement. No kidding. So we can have a great architecture, but if it's too expensive, no one will run it, right? And if you try to lift and shift a traditional application to the cloud, it becomes extremely expensive. Now, about serverless. What we can also do with Lambda, because pay-as-you-go means every developer can have an own production environment, and it doesn't cost anything. But it is less likely that every developer gets an own private Kubernetes cluster in the cloud, right? So with, let's say, with Kubernetes, you are forced to create your own local Kubernetes cluster. And what I know preached for years is, if your local environment is too different to the production environment, problems start to happen, right? And this is why I don't try even to distinct. The question from Jan: do you see Kafka a lot on premise? Yes, and I see Kafka more and more in Jan asked me, do you see Kafka on premise? And I see more and more the nice Kafka use cases. Not like back then I got asked, why I'm using JMS, Kafka is better, which is absolutely questionable. But we use actually on premise Kafka a lot, and what we do with Kafka is we use Kafka streams and sometimes even KSQLDB. So we are using, I would say, lightweight analytics with Kafka, and we use Kafka as, how it's called, I don't know whether it is still, I don't know what data lake is still a thing, but something like a data lake. So we use Kafka as a database. Works well. Interestingly, in the cloud, we don't use Kafka a lot in public cloud because on AWS, we use Kinesis instead, or for as JMS replacement, SQS or SNS because of costs. So these native managed services are usually cheaper than Kafka. So monthly costs become the main non-functional requirement. So I get another great question from Andre. Cost-driven architecture, hopefully, seems to be bad for very high loads. Much higher prices, but good for small loads, sometimes almost free. Now, let's see. So what you have to know, I'm not working for Netflix or similar. So most of my clients are enterprise clients. So if you go to AWS Lambda Calculator, cost calculator. No, we need this one. And my estimate. And not Ohio rather than, oh, Stockholm. I guess Stockholm will be crazy expensive. I don't even know. I do Frankfurt, and we can change later. Without a free tier, because with free tier is 1 million requests free. So architecture, Java runs fine on ARM. This is what we usually use. And now it comes. What I say, for enterprise applications, 2 transactions per second on average the entire month are actually a lot. Right? Because this is on average the entire time. So not 2 per month, 2 per second. Now, duration of each request, I would say in Lambda, if there is no database involved, I would say 200 milliseconds are actually a slow Lambda. Now, memory, because how Lambda operates is, if you have to buy more memory to get more CPU, in most of my projects, we are running Lambda with 1 virtual CPU, which corresponds roughly to, let's say, 2 GB, 1.8 GB of RAM. Currently, we use 1 gig. So let's see. And now let's see how much it costs. It would cost you $15 a month. But this Lambda is already a microservice. So with 2 requests per second, so there are several millions requests in a month, right? So, and I'm just curious about Stockholm. Change region. Oh, it's a €3 more. So you're right. If you're in Stockholm, be careful, right? So, but it's still more architecture. You see, in Stockholm there is no ARM. This is the reason why it's more expensive. Interesting. And in Frankfurt you can use the Graviton processor, which is a little bit faster. So I also recorded on YouTube a screencast about that. And yeah, $15. Okay. So I would say for higher loads, it's more expensive, but what is the cheapest possible solution on AWS? The cheapest possible solution is buy an EC2 Graviton machine, 3 years in advance with S3 bucket, and you get the cheapest option. And the next one is going to be, the Spot instance. You get 80% off, but you will have to buy everything from scratch. So the cost is going to be, lower, but you are in charge of security, operating system patching, maintenance, and everything else. So I would say I'm less interested in it, right? So I'm less interested. If I explain it to my clients, they are less interested in it. So, okay, no, then we pay 20% more. This is actually the difference, roughly, and go with thin wall architecture, right? Okay, where are monthly cloud? Okay, perfect. Now, Java, where Java shines. If you take a look at this is from AWS, and this is actually what they do. They have, this explains a Python architecture, and if I take a look closely, they believe that in Python, you can create a Lambda for post, put, whatever. For every, HTTP small request, you can have a, you ship a Python function, which would mean, for us, for an average microservice, I will have to ship, I don't know, 20, 30 Lambda functions, which is a lot. So now in Java, we don't do this. So we put as much bytecode as possible in a function, and it still seems to work great right now. Why this? Because in contrary to JavaScript or Python, we are custom in Java to build larger systems. So even if we build, a small system, it's still, 200 classes, which is tiny in comparing to larger enterprise systems in Java. So 200 classes on a Lambda is a huge Lambda, but a small Java system, completely maintainable. And this is why we are so productive with Java on Lambda, because, we have one zip and there is one microservice, and we don't care about the load balancer, nothing. We have just one thing, right? Okay. There are the workshops. So that's the last slide. And now I would like to show you some more code, relevant serverless Quarkus code, the next step. Okay. So, Andrei, I hope you know where I'm going with it. Of course, if I get, 10 transactions per second, I will already have to pay 75 euros. But the difference between Lambda and, let's say, Kubernetes or Docker is the Lambda is executed in with 2 GB of RAM and 1 CPU. If I get 2 requests per second, I get 2 CPUs and 4 GB at the same time. This is what I'm paying for. And 10 requests, and I can have up to 1,000. This is the artificial limit per account, but I can increase it. 1,000 processes, not threads, processes. So in Lambda, I can increase the RAM to 10 gigs. I get 4 CPUs. If in my account, I can start 1,000 Lambdas. It would mean I got 4,000 CPUs and 1,000 multiplied by 10 gigs. What is it? 10 terabyte RAM, I think, right? Gabriel Lampa from Brazil. Welcome to Stockholm. Hopefully you can deal with the weather, because, Brazil is probably warm and Stockholm probably crazy cold right now, I can imagine. Although, I don't know, the last time I was in Stockholm, Java user group, also where Victor invited me, what I remember, it was extremely warm. It was like 4 years ago. It was also in April, and it was like 20 degrees outside. Okay, now, Lambdas. Take a look on this. So this is code from Amazon, which some of the JavaScript Lambdas and some Java Lambdas look like this. So this is, the lowest level Lambda you can probably get is like, the servlet without, how it's called, generic servlet, not the HTTP servlet, the generic servlet. It just listens to streams. So this is the most generic Lambda you can get. And having said that, I'm absolutely not interested in writing such a code. And by the way, I reviewed last year some TypeScript Lambdas, and they were written like this. So I know there is a JSON event, and there was a huge switch case, and in case of get, they do this, post do this. I said, okay, we did it in Java, before struts, before struts became available, and now do it again. Absolutely not interested. So I would say this is a very special case. And how Lambda operates usually, you get a JSON event in asynchronous Lambda. And today, I would like to show you something different. So you can all do this. So I can actually put also something to the chat. So in Stockholm are 7 degrees. In Germany today 11. So at least warmer here. And in Brazil there is rain. And in Germany there was a very dry. So yesterday was rain. And interesting enough, yesterday we had like a Sahara sand, which is also interesting phenomenon. So let's see, maybe tomorrow we will get, some snow from, I don't know, from the South Pole or something like that. Okay, or from Stockholm, Now, okay, this is the URI I wanted to show you. And you can just clone it, and you basically get exactly the same this is explained, and there are some, some screencasts. And I would like to show you this right now. Okay, now, by the way, because I see this, Jeff, because serverless was so controversial, in one point of time, someone started a JeffConf, which was a serverless conference, no kidding. And so Jeff, you are legendary, actually. Wait a sec, JeffConf. Let's look at this. Jeff, you are great. It was... you see? JeffConf is an attempt to move past the word serverless and focus on the use of these platforms and the value they provide. So we are absolutely on topic here with the Java user group. Okay. Now, what I'm doing right now, this is a script which basically clones the repository I showed you right now. So, so how to call it? JUG stockconf. This is our answer to JeffConf. So, and what it does, it creates 2 projects. One project which looks like, I'll show you this in a second, which looks strange. This is the wrong one. What it does, it creates the Lambda, which is asynchronous Lambda. You see, this is the asynchronous Lambda, and what I wanted to show you is the Quarkus one. So this was a mistake, but it's also my repository. But so the stockconf, we have to rename to async stock. And now set up Quarkus. This is Quarkus Lambda. This is where, and this is going to be the true stock conf. Okay, this should look better. Actually, the other example I will explain in the workshops, because this is the true future. The Quarkus is interesting, facade to the cloud, and then we are working with asynchronous Lambdas. So now take a look. Now we have here the greetings resource. As you can see, identical to JUG-SORES. What I even did, I created a greeter to show you that dependency injection is working. Then there is a MicroProfile config with some injected values. And you can, of course, use MicroProfile config application properties here. No problem at all. So I could override that. And this is basically it. So this is a stock Quarkus project. The only difference is this here. It uses a specific extension, Quarkus Amazon Lambda HTTP. This is the only difference to stock Quarkus. Now, there is another Java project. It's called CDK. Stands for Cloud Development Kit. And before the show, I updated the libraries because it moves fast. So what I like, it comes from AWS. So if you are running on AWS, it is the AWS standard. So similar idea to Java E. So I only have 2 dependencies. They are a little bit more because I'm using newer stuff, but usually you only have the CDK and the constructs, and this will disappear soon, hopefully. So now, and take a look at the app. So what the app does is just a main method. I set up some tags, and this is stock Java. And I say I would like to run in a region which is configurable. And this basically it, right? So if there is environment, I pick it. Otherwise, I don't use it. And there's the CDK stack. And the CDK stack, what it does is it creates now a Lambda with the name Lambda greetings boundary, and now rename the Lambda to Stockholm. Stockholm JUG. So what I'm also doing, I say a run with 512 megs of RAM, maybe 1024. So this is a good starter, but 1024 is almost production ready. So we're using currently, and if you need one CPU, I use 2 gigs. Timeout 10. And what happens here behind the scenes is I'm actually, this is all you have to do. I'm creating a function with the zip. The zip is created by Quarkus. And the handler here is always the same. It is IO Quarkus Amazon Lambda runtime Quarkus stream handler request. What this is actually a Quarkus implementation of where was it? You know, of the Lambda I showed you earlier. Close the tab. So Quarkus implements the Lambda streaming interface, and what Quarkus does, it parses the HTTP JSON events, and without reflection invokes the JUG endpoint. So therefore, I can use whatever MicroProfile application I have, not whatever, but there are some limits. But stateless MicroProfile request scope MicroProfile applications, which are invoked, you know, per method. So, and I have to use either HTTP API gateway. What you should prefer. And in some projects, I have still used REST API gateway because REST API gateway integrates better into the private virtual network. But if you are running, you know, in a stock environment, always pick the HTTP API gateway. What Lambda is also capable to do, a Lambda can be invoked by a load balancer, which it's really interesting. So you can even have, you know, one single load balancer, one Lambda, and an ECS Fargate, for instance. And a load balancer can switch the load between them, and you can even reconfigure, you know, the load balancers that at night the Lambda is active, and the day, you know, Fargate to lower costs or something like this, right? So but mostly we use just the Lambda here. And this basically it. So actually you can only run with the HTTP API gateway. You can delete the REST option here. So the entire configuration pick, you know, it takes 60, let's say 70 lines of Java code. And the interesting part is Maven. And because it's Maven, it is reusable. So what we are actually doing is we are creating reusable modules, constructs, and submitting them to a Nexus or Artifactory or Maven repository, whatever you have, and then you can reuse it. So not like we are writing this code over and over again. You know, you can if you extend not from stack rather than from a construct, you can make it completely reusable. And this is truly reusable. Why that? Because, you know, all the Amazon REST APIs are the same. So they are identical. So you can write your construct once and reuse even across different clients. Bruno asked me, is it feasible to use AWS Lambda to create an application with a single endpoint that receives an ID, save the ID in Dynamodb and publish it in a Kafka topic? Absolutely, but you don't have to publish into Kafka topic. If you go this route, you can have a Lambda which writes to Dynamodb. Then you can use Dynamodb streams, which automatically is like Debezium, just configurable, which writes the ID, let's say, to Kinesis, and have another Lambda which listens to it, and or I'm not sure whether you can redirect Kinesis to Kafka, but you could absolutely do this. Yeah, it sounds like a good idea, and yeah. And with a single ID, maybe you could even skip Lambda and just use Event Bridge. and this event bridge could write directly to Kafka. So you can even skip, you know, in your case, the Quarkus part. So we can delete more even, right? So very good, Bruno. And I think you're registered to the workshop. We can talk about that. So in May, I plan, you know, to show you some DynamoDB and event-driven stuff. Okay. I have to say thank you, chat. So it was really this is the most interactive Java user group ever so far. So which is great. Now, let's see. I would like to deploy it, and hopefully it's the right account. It will take a while. And I forgot to log into my cloud, to my cloud, and to my cloud. So I will disappear for a second, and log in and show you my account in the real time. So let's see. So you hear me probably, but I try, you know, to find my credentials to log into the cloud. In a second, it should work. Okay. I knew I forgot something, and what I forgot was the login. Almost there. And I'm back, and there is JUG Stockholm 24 seconds ago is deployed in my account. Now, Adam, sorry for silly, someone asked me. First, there are no silly questions. By the way, this is now the endpoint. And what I would like to do is to call it the very first time, and you will see how slow it is. This is the worst possible case. We get the cold start. So let's do this. Time, curl, this one. And the name of the endpoint was hello. And this is the worst possible case. I would think around 5 seconds. And it was, 5 seconds in total. So this is the worst possible case. So let's do it again. And now, you know, the Lambda is warm, and we get on a half CPU with the entire MicroProfile Quarkus response time 150 milliseconds. So we are faster than this what I calculated before. And we are running with 50%, which I calculated before, right? Because I think I deployed this Lambda with 1 GB of RAM, which gets a half of a CPU. But this was the entire process from scratch, you know, to deploy a Quarkus as Lambda. What's interesting here is, what is it, right? How it is working. So, and if you take a look, what Quarkus did, it created function zip. It just packages the business classes like almost thin war. It is like, you know, thin zip, and publish it as a Lambda. And the Java 11 and everything is already installed on AWS. Now, the cool story is, what about testing? So people ask me, do you use local stack on how you test locally? The cool story is, with Quarkus, I can actually say compile Quarkus dev. And my entire MicroProfile application can be started locally. This is exactly the same application. So you don't even, you know, don't need anything special. So you can run, you know, the Quarkus now locally. And I can actually say, no, curl localhost 8080 hello, and get the answer locally. Hello Quarkus on AWS. And once again, and this was the hello Quarkus on AWS from AWS. Now, we got another question from Andri Maluta. And I'm sorry for silly common question. So no silly questions again. But all this serverless stuff and complex backends logic being done for us by clouds. don't you spend more time in JS World Web Components lit HTML? No. It looks simple here, where you will spend a lot of time, where I spend a lot of time, is infrastructure. But we get problems which are driven by features which we didn't have before. Let's say, what I showed you right now is fun, but in production environment, what we get, for instance, we have a fully, the pipeline is serverless as well. So it's called code pipeline, right? And let's say, what you have to do is, you will have to integrate the code pipeline with code commit, Bitbucket, or GitHub. So this has to happen, right? So now, to be secure, now it comes. The code pipeline usually runs in dedicated AWS account. Now, if the pipeline is running in dedicated AWS account, how the pipeline, can access the other account? So you will have to create a cross-account pipeline. Now the question is, how many permissions would you like, to add to the code pipeline? So you are fiddling with stuff which you didn't have before, but you are increasing the security. Of course, I could ship Jenkins and say, hey, Jenkins, you are the admin. But if someone hacks the Jenkins, everyone, then you are toasted, right, in the cloud. Or, for instance, in another cloud, we will have to use, AWS Fargate in private VPC. And the additional requirement is to have, private VPC and VPN connection then, because, how to access your Docker container, right? But if you have private VPC, the question is how the Fargate can access the Docker registry, because private is private. Usually you go over the internet, so you spend some time and you will have to create, ECR, KMS endpoints, S3 gateway endpoint, and you will spend a lot of time, with the infrastructure. So I would say it's not boring. But I would say if you spend some time with it, the result, you get features which were not possible before. Of course, you can ignore everything, and install Kubernetes and run as an admin, for instance, right? But I would say this is no significant added value. Okay, Andri, thank you. But and in web, right now, this year, I focus almost on Java again, Java 17 completely. And by the way, we're running Java 17 on Lambda as possible. There is a Java 17 layer which you can use. And but the web components will come again. But right now I don't know. We just spend the entire time on the cloud. So Jeff asked me, my cloud skills are not that good. They don't have to, I would say. And getting connected to a database in AWS is challenging. Is there a simple option for persistence for AWS Lambda? So right now we use S3. If you use RDS, then you can just use Postgres, no difference. And you can use just your JDBC driver. What I would think about is, what I told you already, we can get 1,000 lambdas, which are independent from each other. So then an idea, what you can do is, if you're running with stock Quarkus, set the connection pool to 1, because there is no point of connection pooling in Lambda. And to increase security and scalability, because every Lambda, as long as it's hot, it will reuse the connection. But if it's cold again, the connection has to be reestablished again, which is not a big deal, but it's suboptimal. There is a thing called RDS proxy, which you can look at. So, having said that, running a Postgres database in the cloud can become expensive as well, because you need to know the CPUs which run all the time. Therefore, it is really worth in the cloud to look at, in AWS, at DynamoDB, Azure Cosmos DB, but DynamoDB is like, the mother of all databases, I would say, NoSQL databases. React and all the databases, they are actually based on the DynamoDB papers. Cassandra is very similar to DynamoDB, for instance. And DynamoDB, so what's the difference? If you would like to have RDS on Amazon, you will set it up with CDK, by the way. You can set up, you can automate everything, but it will take, 10 minutes. So if you run, the RDS in standard mode, there is a leader follower, and you have one node where you can write, and I think the default is 5 nodes where you can read. And it's a little bit, takes a while, and you have to pay more. With DynamoDB, you're just saying, I would like to have a new table, and you get the table. And from the security perspective, DynamoDB, more is possible. Because why? Because DynamoDB is accessible via REST. Postgres database is accessible via JDBC, via binary protocol, right? So in DynamoDB, because it is accessible via the AWS REST interface, you can secure every call. With JDBC not, because it's binary protocol which is hidden, but it goes too far. But if you like, join the workshops. We can talk the entire day about that, but today we don't have too much time. Now, Christian Kaiser asked me, you talked about local testing. What if you need several lambdas need to be tested, how they work together? How does your local setup look like, or do you try to avoid that? No. Right now we use one single lambda with persistence, and it works great. What we usually do in most complex architectures, then every developer gets its own AWS account, which is part of the organizational unit, which can be maintained at once, and you can actually deploy the entire production environment in your account. So you can do whatever you like in your own account. It's completely isolated. And now it comes. You say, crazy, right? But not with serverless. Because it's serverless, it doesn't cost you anything. What the highest cost will be probably if you're running, your VPC in a private mode is the VPC itself, which is roughly 40 euros a month at most. But if you don't have the private VPC, it will cost you exactly nothing. This is what I'm doing for several clients. So I actually have one account per client, and I can reproduce the entire serverless environment inside the account, which is less possible with Kubernetes or Docker because it's too expensive and it actually takes too long to set it up. So Christian, thank you a lot. Any other questions? Because I forgot the time. We are, I think, way over time. So yeah, but it's always fun if the chat is active. So tend to forget the time. I think it was scheduled for 1 hour. We are already 50% over time. So let's see. I think we covered a lot. And yeah, I would say thank you a lot for the questions. If you like, join. There are still, the AirHacks live in end of March. If you like, it's a virtual workshop. Is similar to this, but interactive. So it's different software. So I will also see your face if you like. And then in May, it's just more, we go through all the use cases, and then we'll talk about serverless events, asynchronous and synchronous lambdas. With Java, of course, MicroProfile, no crazy stuff, no YAML. Okay, I think we are done. If you have any questions, then it was a lot of fun. You have, right after the show, join the Stockholm Java user group and have fun, in Sweden. Or, of course, Umea Java user group. So we had one attendee from Umea. Umu, I think. Umu is pronounced Umea. I think it is right, Umu. So you also, of course, have to join the Umu user group. I would say thank you a lot. See you next time. Greetings to Victor. Thank you, Victor, for inviting me. And yeah, bye.